Hello everyone, I'm Typhoon, and in this guide, we will help you create a fully functional 3-band equalizer in GNU Radio Companion with detailed explanations for each step. The equalizer will control low, mid-range, and high frequencies separately and output both the audio and frequency spectrum visualization. Now we will first launch a GNU Radio Companion. So if it's your first time using ERC, it is located under your system application menu, or you can also start with terminal with GNU Radio Companion command. And here we are. Now here we have a new flow graph created. If you don't have one, we will click on File, New, and GT GUI. And this a blank workspace will appear where you can drag and drop blocks to create your signal processing flow graph. And we will save this flow graph as band equalizer. And we will add a variable block from the block menu, but as you can see here, it's already added. Let's set the default value to 32 kilohertz. This is a typical sample rate for audio processing. This will ensure consistent sample rates across all blocks. And we will also add WAV source block. File source. And from this block library, we have added file source block to this flow graph. We'll double click on it to configure it, and we will provide the path for the WAV file, a WAV file we used in previous lectures. You remember it was some human talking. Yeah, OSR US 8 key. So you can also find this file in the resources section of this lecture easily. And here, the sample rate for this you cannot set. And yeah, that's it. And repeat, set repeat to yes. To create the 3 bands, which is low, mid-range, and high frequencies, we will use band pass filter. And drag a band pass filter block to the flow graph, and we will configure it for the low cutoff frequency to 20, high cutoff frequency to 400, and transition with 100. So this 100 smooth transition between pass band and stop band. And in the gain side, we will use a variable named, let's say, also we will use the variable named low gain, which we will add later. So this will control the gain to control the gain dynamically. And we will also add mid-range frequency band. We will add band pass filter again. And we will set the low cutoff frequency to 400, high cutoff frequency 2600, transition with 500. And we will, for this gain side, we will use a variable named mid gain. And lastly, we will add high frequency band. Let's get another band pass filter from this toolbox and open this block to configure it. And for the low cutoff frequency, we will set 2600 and high cutoff frequency to 10,000. Transition width to 1000. And for this gain side, again, we will use high gain variable to control the gain. That's it. And to allow real-time adjustment of these gain variables for each band, we will add range block, 3 range blocks. So in this range block, let's label it low band gain slider and set this ID to low gain. Remember, low gain, default value to 1, range, and here default value to 1, step size to 0 0.1, 0 0.1, and start 0, stop 10. Click apply, and that's it. And we will do the same to other 2 range blocks. Remember, mid gain, label, let's say uh, mid band gain slider. It's going to be float. We will also change this pass filters to float because by default they are complex, so we don't want that. And start 0 to 10, step 1, and click on apply. That's it. Start 0. Oops. Yeah, we will also change the default value to 1. That's it. And we will do the same for a third range, a block. So the label is going to be high band gain slider. Remember this high band variable we defined in band pass filter. High band. Well, default value is 1, range from 0 to 10. Step size is going to be 0 0.1. Oops, and we also need to set this step size to 0 0.1 as well for the mid gain. And now we will connect the file source to our band filters. And here you will see red arrows. That's easily fixable by changing it to float. We made a mistake here. Oops. High gain. And here we are. And now we will add an add block. We'll drag and drop add block to our workflow. This block sums the filtered signals from the 3-band pass filters, and we will change it num of inputs to 3, and we will connect these band filters to here. change this to float, click apply, and click OK. And now what we left to do is we will need to output these combined signals. So we will first need an audio sync. We will add audio sync block to our workflow. We will set the sample rate to samp rate, and as you can see, it's set by default. And now we will connect the output of the add block to input of the audio sync. And we will also add frequency sync. So we are adding this to visualize the signal spectrum. Now we will configure the signal. We will set the FFT size to 1024, and as you can see, it's already set by default. By the way, higher values give more resolution. If you have more computing power, you can set it to higher values. And here, let's set the title to frequency spectrum analyzer, or uh, spectrum of equalized audio. And here, when you scroll down in this, you will see Y min, Y max, Y label, and Y units. These are two are real and the two are strings. And here, instead of is Y min here, we will change it to -10. And we can also adjust as needed based on the signal strength, so we can change this later. And we will connect the output of the add block to the input of frequency sync. And here we have an type mismatch. That's because the frequency sync type is complex, and we will convert it to float. Click apply, OK, and that's it. But I think we made some mistakes here because the transition width should be set to 10 for each one of them. Same one applies for this first band pass filter. And let's double check it. Yeah, our main problem stays here. That's because the sampling rate should be set to samp rate and gain to low gain. Oops, this not decimation one. Decimation set to 1, samp rate. Yeah, that one was true. Let's check this one, decimation 1 gain. And yeah, that's it. Now let's try it, run it. And here we are.